So just the basics first. So more and more, as businesses are transforming themselves, we see a need for not just traditional analytics, which largely was driven through the entire set of data warehousing systems. Increasingly, we see that event data is becoming significantly important for a lot of in a number of different applications, particularly because of the fact that devices and servers and are sort of ubiquitous, and worldwide almost everybody has a handheld device. The consumer expectation and motivation for tolerating latent information is shrinking. That's just a general pattern that I'm sure you're seeing, right from our own behavior, from the time that we, get up in the morning and look at information and how we consume different types of data. So more and more, what's happening is that information and data are coming to us in a continuous manner. And so you sort of, look at the world earlier, you would have a lot of this data sitting in databases, and you would have, query expressions on top of the data. Largely, at least at a simplistic level, most of that would be in schemas and tables, and you would query them. And then there was a bunch of optimization problems and things that people have done over the last 40 years. On the streaming side, data tends to come in as events, and what's interesting here is that this is often just it's going to keep coming forever. And so this is what we call sort of an unbounded data problem. And the challenges and interesting problems to solve here. Number one, how do you do this at scale? If you have a tremendous amount of events that are coming in from multiple different types of sources, applications and servers and logs and mobile devices and sensors and databases. How do you handle that? And number two, how do we actually make use of this data so that we can have decisions in real time? Okay. Just a very quick motivating example you guys can relate to. If you try to purchase like a very simple ultra slim lightweight rubberized hard case cover, you can go to Amazon and you can see the price is in this scenario 1184 with some deal. And then the similar item on eBay is at 1999. I'm not going to predict what choice you're going to make, but if you take a look at how businesses want to react to it, right from trying to look at these pricing updates from their competitors, via different techniques, what ends up happening is that you want to actually adjust a lot of this stuff in real time, including your pricing algorithms, and make them more dynamic. A lot of the times, the profit and loss analytics needs to be done, and literally this can translate into thousands of queries to kind of to recompute a number of aggregates, and oftentimes this may also tie into some recommendations and changing models and whatnot. So fundamentally, the impact analysis decision latency has shrunk, and that's really the motivating example here. And one of the things that I'm going to touch on about the database part of it is a lot of the information and the data needed to react to these kinds of problems tend to be in events in databases. So if you can access that on a continuous manner, then you can incorporate them in these algorithms. Otherwise, you're going to leave that data to sort of more slower moving technologies. I'll get into the guts of that. I just want to set the high level problems here. So there's a great paper in Sigma 20 for those of you who really want to understand the evolution of stream processing engines and stream processing systems. And there are like 3 generations mentioned. The title of this talk is Next Generation Engine. So I really think that we are on to the 3rd generation here.